Hi guys, and welcome back to another lesson in geometry. In today's lesson we're going to further extend our understanding of gradient and how we can find gradient. There's many different ways, but I'm going to teach you a couple more ways that we don't know yet. So we know that to find the gradient we need to find the rise over the run. So rise over run. So this is the rise or fall, because it can be a fall as well, and the run, which is like a vertical. If you were running, you're not going to run up a wall, you'll run along the ground. So that's how I remember rise and run. The sun rises up and sets down, and then you run along the floor. So the run here drops by 2, so it's -2 over 1, 2, 3, 4, 5, so over 5. So our gradient here is m equals -0.4. Now I'm happy for you to leave it either as a fraction or a decimal, but remembering that if you leave it as a fraction, it must be in simplest form. Now there's a second way that we can find the gradient. Okay, so we use the points 1, 3 for k and 6, 1 for L. And we use this equation here. So m equals y2 minus y1 over x2 minus x1. So x1, y1, we're going to label these as our x1, y1 coordinates, and these as our x2, y2 coordinates. Okay, so these are the first ones we're working with, and these are the second ones we're working with. So remembering that y comes first when we're doing this, because it's rise, which is fall or rise, or over our run, which is the vertical. So our rise is 1, so our y2, 1, take away our 3, which is our y1, over 6, take away 1. So you can see here that when I did the y2, y1 and the x2, y1, I started with this coordinate here, and then I subtracted these ones. I can't go 1 take away 3 and 1 take away 6. That won't give me the correct run. So I have to be careful that I use the same coordinates first and the same coordinates second. So 1 take away 3 is -2 over 6 take away 1, which is 5, so we get -2/5 like we did before, and we end up with -0.4. Okay, so it's your turn now. So I want you to calculate the gradient of a line segment joining 3, 2 and 9, 5. So the first thing you're going to do, write down your formula like this, and then knowing that this is x1, y1 and x2, y2, you're going to pause it, substitute those in and see what value you can get out of it and find out the gradient. So hopefully you put 5 take away 2 over 9 take away 3. M equals 3 over 6 because 5 take away 2 is 3, 9 take away 3 is 6. So we end up with 1/2 or 0.5. Now we're going to swap these values and make this one now our x2, y2 and this one our x1, y1. We're doing that because I want you to see that it won't matter which way you do it. Okay, so I want you to pause it again, substitute those values now, the different ones, into here and see what you come out with. So you should have had 2 take away 5 over 3 take away 9, which gives us -3 over 6, and we know that 2 negatives make a positive, so we end up with 1/2, and it's a positive half, or 0.5. Another way that we can find out the gradient of an equation or a graph is to look at the structure of our equation. So this here is our gradient or our slope, so the number at the front of our x is our gradient or slope, and the number on its own is our y-intercept. So our constants are our y-intercept. Now it's important to note that when you do this, you need to have y on its own over here, and you need to have one constant. Okay, so pretty much 2 terms over this side. So your x term and your constant term. You can't have 6 and 4 and 2x and 3x. You need to combine them, collect like terms before you can do it. So for each of the following, I want you to identify the gradient and the y-intercept. We will do the first 3 together, and then you can do the last 3 on your own. So the first one, y equals 2x minus 3. The gradient is 2 and the y-intercept is 0, negative 3. And you can see that I wrote the intercept as coordinates. The y-intercept is not negative, well, it is negative 3, but it is also a coordinate because x equals something at negative 3, and we have to say that here. The second one, so y equals 2x over 5 plus 4. Our gradient is 2 over 5. So essentially our gradient is the whole fraction without our x symbol there, or 0.4 as a decimal. And our y-intercept is 0, 4. Our final one is y equals 9 times 9 brackets 2x plus 5. We're going to expand it first, so y equals 18 plus 45. Our gradient is 18 and our intercept is 0, 45. So now I want you to pause it and do the next 3 on your own and then come back. So the first one, remembering that with all fractions, there's actually a number 1 out the front, or sorry, all pronumerals. If there's no number there, or no coefficient, it has a coefficient of 1, which means that this is 1/10 or 0.1 as a decimal. That's our gradient. And our y-intercept is 0, negative 6. Now what this means is that for every 1 it goes up in our graph, it goes across 10. So we'd have quite a low slope. Y equals 2x minus 12, so we expand it to get 2x minus 22. I meant to say 11, not 12. And m equals 2. So our gradient is 2. Our y-intercept is negative 2, 0, negative 2. And our final one, y equals 3x over 4 plus 9. Our gradient is 3 over 4 or 0.75, and our y-intercept is 0, 9. So hopefully that helped you with some different ways of how to solve linear equations and find the gradient and y-intercept. If you have any questions, make sure you ask. Otherwise, we'll see you in the next video. Thanks, guys.